Okay, guys. So we're back from the break or the Zoom break. So we were on the discussion of hypothesis, and we were saying that our hypothesis would be an educated guess. So generally, an hypothesis is something that you formulate, an opinion that you formulate about what you think happened. And oftentimes, an hypothesis generally comes when there's a problem. So generally, you start off with a problem, and the problem is there, and your hypothesis must probably say why the problem exists or what caused the problem. So most of the time, your hypothesis is really trying to figure out what is happening or what causing a problem. And so you're trying to figure out the truth behind what is causing the problem. So you come up with your hypothesis. So you formulate in your mind based on using some kind of intuition or your common sense, and then you put two and two together and you say, all right, this must be it. But oftentimes, because your hypothesis is going to be more like an opinion, give me a second, guys. Yes, as I was saying, sorry about the interruption. So because of you coming up with an hypothesis, oftentimes you need to test your hypothesis, and you need to carry out an experiment to check to see whether or not what you're saying is correct. So for experiment, there is a particular order in which we carry out experiment, and in the scientific world, we say that it obeys what we call an empirical formula. An empirical formula in an experiment. Can anybody walk me through how an experiment is done? I'm going to ask Ms. Nelson, since she might be the one with a little bit more knowledge of that. Go ahead, Ms. Nelson. Walk us through an experimental process.
All right, I'm going to go from memory. Based on memory, when we're normally doing experiments, we normally have the devices that we need, the things that we need. We normally speak about the theory or opinion and what we expect, and then we normally do the experiment to see if our opinion is true or if it is false.
All right, so before we reach all of that part, we're going to start off with a title for the experiment. And generally, the experiment title going to be based on what your hypothesis is, right? So let's say that you have a plant, right, in a pot, and you have it someplace in your room, and one of the day you realize that the plant is wilting. The leaves are kind of getting pale and looking as though they're going to dry up or something like that. And so clearly there's a problem happening while the plant is looking that way. What kind of hypothesis would you come up with that probably causing the plant to look that way? What's your educated guess? Go ahead, Ms. Morris.
Sir, maybe it needs water and sunlight.
Right. So that would be the hypothesis, right? Now, so to test your hypothesis, now you would have to carry out an experiment. Now, when you're going to start your experiment, what would your title be? What would the title of your experiment be? Go ahead, Miss Morris. Repeat what your hypothesis is, Miss Morris. What you say?
So it is to give it water and sunlight.
So you're saying maybe the plant is lacking water and sunlight, right? That's your hypothesis, right?
Mm.
How,
Yes, sir.
how can we go about now an experiment to say whether or not it is sunlight or water affecting the plant? So what you're going to start off with is your time.
I'm not hearing you at all. Don't know if you're hearing me.
I'm hearing you. Are you hearing me now? Miss Nelson, are you hearing me?
Yes, I am.
All right. I think there's a connectivity problem between me and Miss Morris. Miss Morris, are you hearing me now? Miss Morris, are you hearing me?
Mr. James?
Yeah, man, I'm hearing you, Miss Morris. I realize Mr. Arthurs, are you hearing me? All right, Mr. Arthurs is hearing me. Are you hearing me now, Miss Morris?
Yes, sir.
All right, so as I was saying, you have your hypothesis. Now you want to set up an experiment. So my question to you is, what would you give what name would you give to the experiment? What title would you give to it? You need some,
To this experiment.
do you need some help?
Sure.
Title has to relate to your hypothesis. So your title may be, what was your hypothesis?
You're gone again, sir.
You're hearing me now? Are you back yet? Are you hearing me now? You're hearing me now? Miss Morris? All right, you're not hearing me. You hearing me yet? Check your device. Are you hearing me, Mr. Morris?
Barely, sir. Barely, no.
All right.
You're coming in piece by piece.
Right, so that's an internet issue. All right, you still hearing me?
I hear you a little bit. I hearing you a little bit, sir.
Okay. So your title would be to investigate whether or not lack of water and sunlight is causing the plant to wilt. That would be a title, right?
Okay.
You're following? So remember now,
So basically, your title would be your hypothesis.
right. So so your hypothesis is what you're investigating. So your title should be investigating your hypothesis. You following?
Yes, sir.
Right. Because what you really want to do is to see whether or not your hypothesis is true.
Okay.
Does that make sense?
It does.
Right. So now, the next step now is that you have to plan and design an experiment. of how you could test that hypothesis. So what would you do to the plant? What kind of treatment would you do to the plant to test it, whether or not it is lack of water or lack of sunlight? Or what would you do by way of experiment to test that?
So I would take it out of the room
Over
and
to a
take it outside.
location, right?
Put the water on it and then leave it a little to see if actually that's what it needs.
All right, so would you try to investigate either sunlight or water? Would you give both treatment at the same time?
Maybe I would.
But
I would take
wouldn't
it.
that create a conflict? Because you would know exactly which one of them is causing. So if you do them one at a time.
But sir, what is the possibility that it is the both of them is the cause?
Well, that's what I'm saying. You could test one, you could test the other, or you could test both. So you could test them individually and then both. And then now you record or you observe what changes you would have seen.
Okay,
You follow?
understood.
So what would you need to set up that experiment? What kind of material would you actually need?
You would need, well, if we're gonna test it with the water first,
You're going to need water.
we're gonna need the water.
You might
Because,
time to put the thing on.
right.
Right. Now, in experiment, we would call those your apparatus. So the things that carry out the experiment, the equipment and all of that would be your apparatus. Your experiment would start off with the title, then the apparatus, then what next now? So you may want to look at a procedure. What a procedure would be, what are the different steps that you're going to take in carrying out the experiment? What you're going to do first, what you're going to do next, what you're going to, so it's a procedure is the step-by-step process of how you're going to do the experiment. You following me?
I am, sir. I'm listening to you.
Right. Now, after you carry out these procedures, then some procedure might require you to measure stuff. Some procedure may require you to calculate stuff. Some procedure may require just a simple observation, just looking and writing down what happened, right?
Okay.
Now, those information that you get from calculation and observation, those now become your data. So when you collect those data, you might put them in a table or something. And then now once you put the data in the table, you're going to analyze the data. And based on what the data calculation showing you in terms of measurement and so on, then you are going to interpret these measurements. So you analyze them, you interpret them, and then now you're going to draw some conclusion about them. So when you draw your conclusion, in your conclusion, or before you draw your conclusion, you would have what we call a discussion. So the analysis and interpretation, then you discuss what you think possibilities are, what could cause what, and so on. And then now, when you're making the final conclusion, you need to state whether or not what the discussion you get from or what the data is saying, is it supporting your hypothesis? Is it that your hypothesis is true or false based on the data? And so if your hypothesis is true, then you may want to make some kind of recommendation as probably what to do to prevent the wilting of the plant. You may also want to talk about some limitations, some things that probably would have went wrong during the experiment that probably could have affected your data. Maybe you weren't measuring it very accurately. Maybe the device that you used to measuring wasn't very perfect and so on. So all of these things now you would discuss in your conclusion. And then now you make a recommendation to in terms of anybody else who would want to carry out your experiment. So at the end of the day, you might say whether or not, your conclusion should say whether or not your hypothesis is true or not true. Now, in carrying out this process, you have to be objective. Now, in science, when we say objective, can anybody explain to me what being objective means in science? Can you explain that to us, Mr. Nelson?
Right. In my opinion, being objective is having your opinion and not sticking to what somebody else says.
Well, unfortunately, that would not be the case, Miss Nelson. What really should be the case is that being objective, you should not have an opinion. You should just state what the data is saying based on what you're seeing and what the numbers are saying. So to say exactly what you think is the outcome would just only give in your view, but not necessarily what the data is saying. So when you carry out an experiment, you want to say what the data is saying. You don't want to say what you think is happening, because an opinion would not be a fact. So for experiment, you're trying to come to the truth, and the truth has to be supported by facts. Is that clear, Miss Nelson?
Yes, sir.
Right. So would that summarize the whole process of an experiment to you guys? Raise your hand if you get an idea of how to conduct an experiment. All right, Ms. Mars. Okay. All right, so scientists in general, whether it be physics, biology, or any kind of science you may think of, coming to the truth must be opinion free. It must be based on the experiment, the facts that you get from the experiment. So if another scientist wants to see whether or not what you claim or the conclusion you make from your experiment, they want to see whether or not your experiment was accurate, what the scientist would probably do is to follow the steps that how you design your experiment. So in other words, you should be able to give to another scientist all the steps that you would have gone through in carrying out your experiment. The other scientist should be able to follow those steps and go through the same process of analyzing and interpreting and discussing the data. And when they come to a conclusion, they should be able to see how you came to your conclusion and why you say that your hypothesis is correct. So at the end of the day, the scientists want to be able to test your experiment. So for that reason, your hypothesis would not be considered true until a number of scientists would have tested your hypothesis by way of experiment and agree with it. You get what I'm saying, guys? Raise your hand if you understand what I'm saying. Okay. Now, so what we have here for an hypothesis. So an hypothesis is an unproved or preliminary explanation that can be tested by comparison with scientific evidence, early hypotheses are rarely correct. That means when you have an hypothesis, there's no guarantee that it will be correct because it's a guess. And when you're guessing on an exam question, chances are you're going to guess the wrong one most of the times, right? So guessing might not be correct at first, but when you guess a couple of times, you might come to the right guess. And so when you carry out your experiment, the evidence from your experiment should support what your guess was. All right, any question at all? All right, so just I think we have come to the end of the period for this session. But before I dismiss the class, so I just want to say that what will happen is that in the website or on the website, I will be posting these slides in PDF format. And so you can go there and review them. Now, I will also try to post some of the topics ahead of time so that you can read them before you come to class. Now, what is available on the website at this moment? There is a study guide. There is a nutrition and study tips. I would like for you to just take the time out and go to the site and read up on these things to get us some ideas of how to prepare yourself for the whole process of studying and following the whole journey of this class. All right. Now, I will be adding stuff to the site as we go along. I will also be adding some virtual experiments because, you know, this is a lab-based subject, but we may not be able to use a physical lab. But so what I will provide, I'll provide videos of the actual experiments, and you will be able to watch and follow the experiments, and you will have to write up your labs based on your observation from the experiments, right? So you will need a lab book because you will have to submit an SBA if you're going to sit the exam. All right, let me hear what's the question now. All right, so yeah. So is that clear to everybody? And so before we leave, I'm just going to ask, it's just only 3 of you, so I'm just going to ask each of you. I may not get so much response from Mr. Arthur because he will have to be typing in the chat. But let me start off with Ms. Morris. Can you just share with us what you learned from today's lesson? Go ahead, Ms. Morris. Are you there, Ms. Morris? Are you hearing me? All right, Miss Nelson, are you hearing me?
Yes, sir.
All right, why don't you go ahead because I'm not sure what is happening with Miss Morris' connection. So can you share with us what you learned from today's lesson?
All right. I learned that objective is not having an opinion, but just sticking with the facts.
All right. Anything else? That's it?
And I also I'm trying to remember. I also learned that the concepts you have mass, pressure, time. I also learned about those and learned they all correlate with gravity.
Okay. What about the definition for physics? What do you learn about that?
I'm trying to remember. I learned that I didn't trying to remember what's the definition of physics. Sir, I don't remember.
All right. Miss Morrison, are you hearing me now? Miss Morris, are you hearing me?
You're hearing me, sir?
Yes, I'm hearing you now. Can you just give us a feedback on what you have learned from today's lesson?
Learned quite a few stuff. Learn what physics is. Um, Physics is the study of non-living things. It studies matters and energy. I also learn about matter, mass, weight, and energy. I learn also about the laws of gravity and the difference between concept two, the fundamental concept and laws. Um, I've learned uh, I've learned about also how to order, how to do and prepare an experiment. Not fully 100 on that one, but I've also learned the components that would be required to do an experiment. I've also learned what an hypothesis is, and yes, sir.
Okay. Mr. Authors, I know you're not to talk on your mic. Could you just type something in the chat for us about what you have learned today? I take that you're typing, Mr. Authors, because I'm not seeing any response yet. All right, so let us see what Mr. Authors has to say. All right, so Mr. Authors says a hypothesis does not have a final solution to a problem. Well, an hypothesis was not really meant to be a solution. It was meant to be an explanation of what a cause should be, right? So it's just a preliminary explanation of what you think happened or what causing a problem. That's your hypothesis. And when we set up an experiment, our experiment would be aiming to test our hypothesis. And we should carry out the steps by first stating our title, which is relating to the hypothesis. Then we talk about our apparatus. Then we talk about the procedures, which have to do with the steps that we're going to be taking in carrying out the experiment. Then we're going to look at any kind of observation that we get from the procedures. And once we record those observations, then we're going to analyze them, interpret them, discuss them. And then now, having done all of that, then we must come to a conclusion of what the data is saying, whether or not it is supporting our hypothesis. So it must be saying something whether or not it is supporting it to say whether or not our hypothesis is true or not. So we must be able to conclude that. And we also must be able to say whether or not there were things such as errors that affected the experiment that could have thrown off our results. And you must also have a recommendation as to what you could have done better or what could be done better in the experiment and how you would go about the experiment if you were to carry it out again. All right, guys, so would that give you all a sense of where we are going from a scientific point of view? So physics, like all the other science, will follow this investigation experimental process. And so we do this in order to come to the truth. And so the truth will be based on facts, the evidence collected throughout the experiment, not your opinion, because your opinion is just something that you come up with without any facts. So we don't use opinion in our conclusion in science. All right. So this is where we'll stop for today, guys. Any question before we go?